All right, well, welcome back, everyone. Today we're going to be talking about singly and doubly, the single pointers and double pointers, and how we should go about thinking when it comes to solving these kind of problems. So we're specifically going to solve two problems from LeetCode. One of them called the longest common prefix, and the other one, I believe it's a container with the most water. So longest common prefix, it's supposed to be a single pointer exercise. And let's talk about how this works, right? So here we have our exercise. Write a function to find the longest common prefix string amongst an array of strings. If there is no common prefix, then return an empty string. All right. We take a look at our example. Here we have our input of strings. We have flower, flow, and flight. From this, I can see that during the first comparison, the longest common prefix is flow, right? And then when we go into our third comparison or our third word, only FL are the remaining common prefix. So there's our output of FL. Then we can see here in example 2, we have our input of dog, race car, and car. There is no common prefix right off the bat. So I believe we could probably do something to kill our function right after this first comparison and return this, this string here. Now there is no common prefix among the input strings, perfect. And then here we have a little bit of constraints, right? We have our strings length, which we know is going to be less than 200, or less than or equal to 200 words, or that will at the very minimum be one word. And for every string length, so for every string inside of this array, the string length may either be 0 characters, so just an empty string, or up to 200 characters. So there is a possibility in the worst scenario where we would have 200 words with 200 characters inside of them. Okay, awesome. So there's our problem. Now, let's talk about how to address this problem here. If I take a look at my boxes here, I'm going to go ahead and kind of draw what we have going on. We have a couple of strings. Let's just take that first example and talk about it from there. All right, so in the first one, I believe we have flower, then we have flow, and then finally we have flight. We know that the worst scenario could be 200 words of 200 characters. All right, so how do I go about addressing this problem? How could we come up with a solution here? Too early in the morning to start with the brainstorming?
I would say this is gonna but with that large of an input, 200 words, the only idea I can come up with that's not very efficient is turning each word into a list of characters and then storing any of the common first letters inside of like some type of structure and then checking to see what that commonality is and then returning it. But with a large input like that, that's going to be really inefficient.
Well, I very much like your idea. Let's go ahead and type it out, right? So I think you have something along the lines of answer. And what you're saying is from that answer, we would then iterate. So for letter in flower or in, let's just say strings 0. And then from there, we would go into for. I guess we would have to iterate through every single word after that, right?
Yeah, I was saying you would loop through the words and then just turn each of them. Can you do that? I don't remember if you can do that in Python. Can you turn a string into a list just by like typecasting?
Again, yes. So we could say for word in SDRs. Okay. And then from there, what?
I would say um word equals list um list word. Yeah.
Okay. And then how would we compare this word with the next one? Or would it just be a comparison with answer? Okay. Awesome. So there we have kind of a good starting point, right? We're starting to do iterations. But to take into consideration the fact that we have 200 words, we definitely cannot afford to have something like a nested loop,
Yeah,
right?
that's what
Yeah,
that's
because if our worst scenario is 200 of 200, then that means that, well, when we create this algorithm here, we're already creating an n squared algorithm, meaning that as our input gets larger, so does our performance. So we're creating it something like this, right? And that's not what we want. We want something that stays flat and doesn't grow exponentially. Okay, let's hear it, Juan.
Just out of curiosity, because I'm kind of confused as to what they mean by prefix. What exactly is a prefix? What are we defining here? Because FL, I'm pretty sure that's not. Pretty sure those are just part of the root word. It's not like reflow or something, where
Yeah,
re is the prefix.
that's a great question. So the what they mean by prefix is the common amount of letters that the word starts off with, right? So in our first iteration, we have all of flower. So if we were to take a look at Jacob's answer here, right? We would have flower that would then get put into the answer. From there, we could do something like, hey, four letter in answer, if letter not in the point is we would want to cut out the answer to then be flow because flower has flow and flow is just flow. So then the only two letters that would get dropped would be E and R. And then when it compares flow to flight, the only common letters from start is F and L. And that's why our return value is FL. Did that answer your question, Juan?
I think so. And then I'm assuming then you would just assign the first, at least in this case, assign the first instance in the array to be the first character or the first word to compare to, I guess.
All right, awesome. So we would want to say, hey, our answer is equal to SDR's 0, right? Because we already know that that's going to be our very first character. All right, great. So this is where our single pointer is actually being implemented here. By doing this answer to STR0, we are establishing, hey, this is my root. This one index will be where I start off and make all of my comparisons moving forward. So this is called a single pointer. My pointer is aiming to the very first index. It doesn't always have to be aiming to the very first index. It's just a pointer, right? So now let's go about solving this algorithm. So we already have our pointer. And now what we can do is we can iterate through the letters in our pointer, right? So we can say, hey, for, and what we want is the index because we're going to need the index. Or let's just say 4-letter in answer, which is our first word. And then I could iterate through the words inside of my string. So 4 words in STRs. Right. And from here, we know that I want to grab from index 1 and beyond. Because I don't want to do anything comparison. So I do have a nested for loop, but my nested for loop isn't going through the entire list, right? It's only iterating through my very first word. So this is only comparing the very first word. This is the only length here. And this is actually running through my entire array, which is what's nested down below. From index 1 and beyond. So that kind of helps with the for loop, right? Because now if I'm considering my worst scenario where I do have 200 words, I'm not iterating through all 200 words multiple times. I'm only iterating through 200 words once, and I'm iterating through all the characters of one word multiple times. All right, I'm essentially comparing this against the entire array instead of comparing 2 words at a time and then moving forward. All right. So now that I have this information comes the easy part of actually determining what our answer should be every time we iterate through some words. And once we're done, we would just return our answer. All right, does anyone have any questions regarding this thought process?
Real quick, what does it mean for 200 characters? Are we talking like random characters too? Or a bunch of A's in front of everything or something crazy like that? Or is it only letters or not alphanumerical?
So we do know that they're all letters. So here in our constraints, it tells us, hey, str's I consist of only lowercase English letters. So we know that we're accounting for letters. We don't know if we're accounting for solid words. So we do have to account for the fact that it could possibly just be a random series of characters. Let's hear it, Haley.
So you said that it's just looking at the length of that first word. What if, I'm just not understanding. Like, what if the second word is a longer length than the first word?
Got it. So if the second word is a longer length than the first word, right? So let's say that flow and flower were switched up. And in this scenario, we make flow our pointer. Well, if we were to compare flow and flower, if flower is longer, even if flower is longer than flow, we know that the longest common prefix between the two of these would be the entirety of the word of flow. So we don't have to worry about the E and R.
What if the most common thing is like further in the word?
It can't be. So the
Okay.
common prefix is from the start of the string moving forward.
Okay.
Any other questions? All right, if there aren't any questions, let me go ahead and pause our recording. All right, welcome back, everyone. Let's go ahead and put this algorithm into some application, and someone has a hot mic. Oh, there it is. All right, let's go ahead and get that started. So as we talked about earlier, we want to have a pointer where we're utilizing that very first word as our point of comparison. And that's going to allow us to have a nested while loop that won't necessarily run outside of time complexity because it's only going to iterate through the length of one word rather than iterating through all of the words and all of their lengths. So how do we account for this? Well, here we have our function of common prefix. In single point in main.py, I have both of the examples and I have both of the answers. And then I'm just iterating through so I could see some statements down below. Currently, if I run Python main.py, you'll see that both of them come back false. That's because currently my function is just having a pass. So let's turn this into some code. Now, there's a couple of ways to do this. I'm just going to have this answer statement start off as an empty string. I'm going to iterate through the index in the range of str's 0. Now this is going to make me have this very first word as my pointer. So here's my part where I'm indexing through where I'm working with those letters, right? Then I'm going to iterate through all of the strings within the word. So for string, or I'm just going to say for words in strs. And here I don't want to have anything repetitive, so I'm just going to go for 1 and beyond, right? So starting off at index 1 and beyond, because I don't want it to be repetitive. And then I'm going to make my little statement here. So I'm going to say, hey, if my index is equal to the length of my word, well, in this case, I want to kill my function. And I want to kill it by returning the answer. All right. Now, what other condition would make me kill my function or return the answer? Or I'm going to check if, hey, if my word at the current index does not match my pointer of str's 0, nope, and that was double instead of single, at index, then I also want to return answer. Now, finally, I want to build up my answer. So if this if statement is not triggered, I want my answer to plus or equals str's, the very first word, at index. And then I'll just return my answer. All right, so let's check this out. Let's break it out so we can see what's going on here. And I'm actually going to go ahead and copy this code here. I'm going to put it inside of a different code block. I'm going to move this up so that it's not in our way. All right, so there's our longest common prefix. Now let's take a look at what we're actually doing. So in this first for loop where we're indexing through all of the indexes inside of this, all right, we're going to go ahead and roll through. And what we're saying is, hey, I want to go through the indexes of 0 to the length of 4. And then I'm going to kill my function. So 0 through 4, that's all that's happening. 0, 1, 2, oh, excuse me, it's the length of 3. 0, 1, 2, 3. Perfect. All right. So there's my first for loop. In that second for loop, I'm iterating through all of the words. Let me actually make sure that this works before I continue running it. Okay, got it. So I do have an error here. In range len, because that's important. There you go. So it does work. It's returning true. Great. So I'm iterating through 0 through 3. And in that second iteration, what I'm saying is I want to iterate through these 2 words. Remaining list other than first index. All right, so now let's move on to the next block of code. We're iterating through all of the indexes. Now I'm iterating through all of the strings. Well, what is this if statement saying? So this if statement is saying, hey, if my word is longer than the next one, so or is shorter than the next one. So let's switch these up. Let's say we're working with flower and flow, right? Well, at the point where index 3 was met, and in this case, this would be 0, 1, 2, 3, 4, 5. Perfect. So in the case where index 3 is met, it would say, hey, index 3 is the same length as index 5. Where am I at? Here I am. Is the same length as the entire word. Or if the word of index is not equal to the next one. So currently, if I were to FLO, well, FLO is the same with flow, but FLI is not the same as FLO. So it would just return FL. So how is this working if I'm iterating through? How am I even recognizing that that's happening or building up my answer? Well, up here, I have something called answer. And what I'm doing is every time I iterate through these lists, so currently the first iteration happens, what I compare is F in first word. I then also compared F in the second word. And I then compare F in the third word. None of these meet my if statement that I have there to kill my function. So instead, answer gets a plus equals of F. Then I move on to my second iteration. In my second iteration, I compare L in first word to L in second word and L in third word. So again, we go up and now we have F and L being added into our answer. So there's my second iteration. I just went through index 0 and index 1. Let me add that here. This is where IDX was equal to 0. And this is where IDX was equal to 1. Now I go through my third iteration, where IDX is equal to 2. Well, now in this iteration, we're comparing O in first word. We then compare O in second word. And then we compare it to I in the third word. At this point, my if statement is met because now I'm checking word index does not equal the first word at index. So I is not equal to O. So my function gets killed and it returns my answer. And the previous value of my answer was F and L. And that's how that gets returned into my as my answer. Right, I am comparing one independent word against the rest of the list rather than comparing all of the words together at once. That is a single pointer exercise. Does anyone have any questions over this logic or how this code came together? Let's hear it, Jacob.
I guess the only part that I'm confused about, kind of, I understand pretty much every part of the code except for when you're doing the if statement to check if IDX is equal to length of word. I'm not really sure the reasoning behind that logic.
Got it. So if IDX is equal to the length of word, so let's say that this was flowing, right? And it continues on. It goes through this a couple of times. Now this would be O. We would then have index 3, where in index 3, I believe we have W. All right. So now at index 3, we have W, right? And flower and flowing still have other letters remaining. Flowing has ing and flower has E and R. But that statement here checks, hey, is index equal to the length of word? Well, the current index that I'm on is index 3. And if I take the length of this word here, a flow, it's 4, right? So we'd move on to the last statement here. And in that last statement, we would have index 4, where in the first word, which is flower, we would have E. In the second word, we would have none, because it's non-existent. And in the third word, we would have I. Well, because the last one is non-existent, our answer builds all the way up to flow. Because here we have O and W. But when it gets to index 4, well, 4 is equal to the length of the word. So it returns our answer, where the longest common prefix would be flow. Did that answer your question, Jacob?
Yeah, I think the breakdown helped. Thank you. Appreciate it.
Of course. James?
Everything makes sense. I'm confused why, when you're comparing the index and the length of things, you're not throwing a -1 on the length of them, because wouldn't that make them be off by 1?
Yeah, that's a great question. So if I were to place that -1 in that comparison, right? So if I were currently, the length of flow is 4. And let me write this in gold here. So flow length is equal to 4. If I were to put a -1, then that means the flow length would be equal to 3, right? So let's say 4 at -1, then it's equal to 3. All right. So we went through the first iteration. We add our F. We go through our second iteration. We add our L. We go through our third iteration. We add the O. But now when we get through our fourth iteration here at index 3, if we were to put that -1, well, 3 would meet our condition. See that our answer gets incremented after our nested for loop. So our if statement would get triggered, and it would return only FLO instead of the entire word of flow. So that's why we have it to equal the length, because we want to make sure we increment that W inside of our answer. Does that answer your question, James?
Yes, it does. Would another way, if you wanted to keep the -1 for some reason, would a way to fix it also be to, instead of doing index equals length word, to do index is greater than length word? Would that also kind of fix it? Am I thinking of that correctly?
So we wouldn't want to check if it's, oh, I see what you mean. So once the index is greater than the length of word. Well, if you do greater than the length of word -1, yeah, that would fix it. If you do greater than the length of word -1, that would
It
fix
would
it.
look worse, but yeah.
Yeah. All right. Okay, great. Doesn't look like there are any other questions. So let's go ahead and take a breather here before we go into our doubly pointer algorithm, which is going to be the water problem, which I'll share with us here shortly. Currently, it is 9:58. Let's go ahead and come back at 10:10 to continue on with the second portion of our lecture. See everyone back here in 12. All right, welcome back, everyone. Let's go ahead and talk about our double pointer exercise. Now, the concept of 2 pointers when working on an algorithm isn't new to us. We've seen this before. So I just want to make sure that I'm going to preface before we even talk about the algorithm or anything, that you should definitely think back into some of the other things we've done here in Code Platoon, some of the other algorithms we've talked about, and think about which one of them would represent 2 pointers moving through an array. All right, now let's talk about this. So container with the most water. you're giving an integer array of height of length n. Okay, so we have an array of integers. All right. There are n vertical lines drawn such that the two endpoints of each line are I and 0. And I is representative of height I. Okay, so find two lines that together with x-axis form a container such that the container contains the most amount of water. Return the maximum amount of water a container can store. Notice that you may not slant the container. Okay, perfect. So here they give us an example. It looks like our array would be of 1, 2, 3, 4, 5, 6, 7, 8, 9 elements. So we would have an array of 9 elements, meaning 8 indexes that we can actually manipulate through. All right, so let me go ahead and draw this example here. So I have an array. Oh no, that's the wrong color. There we go. All right, so we have an array of 9 elements with 8 indexes. All right, and then they give us the height for each one of them. So at index 1, or excuse me, at index 0, we have 1. At index 1, we have 8. At index 2, we have 6. Index 3 looks like it's a 2. Index 4, 5. Index 5, I think that's a 4. Yeah, it's 4. Then we have at index 6, we have another 8. That's great. All right, at index 7, we have 3. And at our final index, index 8, we have a 7. All right. So there's a couple of things to consider in this example, right? The first thing that I've noticed is that even though these two are the highest points, there's not enough area from left to right in between them to account for the amount of liquid. So we're looking for area, all of the space that gets filled within this box. All right. So 8 would be the highest point of my container that I would be able to fill it up to. But if we look at the number of spaces here, we only have 1, 2, 3, 4, and 5. So 5 times 8 would only give me 40. Whereas in the other example that they're telling me is my answer, I'm looking at the area here. My maximum height would be the smallest pole, which is a 7. But we know the spaces in between is 1, 2, 3, 4, 5, 6, and 7, which gives me 49, right? And we know that 49 is greater than 40, which is what we would have had if we filled up our area in this element. All right, so there's a couple of things to take into consideration there. Does everyone understand this problem? Does anyone have any questions over the problem or what it's asking you to solve?
Don't understand it. I guess just like having a representative number is like, so they're trying to tell us that it's trying to tell us that how is the water stored exactly? I guess I'm just kind of like confused on that part.
Yeah, we're just trying to figure out which combination of two poles, right? The poles being the bars or the height, which is at each index, would allow us to create the biggest container for storing water. The water doesn't necessarily matter. We're just looking at area of container. Does that make more sense, Jacob?
Yeah, thank you.
Of course. All right. So now that we've got our problem, let's take a look at our example here. So we have our input height, and that would have been a lot easier to copy and paste and draw it than the way I did it. We have our output of 49, which is what we expected. We know that the area of 49 is greater than 40, and it even gives us an explanation here. So we have 8 and 7 in case the max area of water, so the blue section the container can contain, is 49. And then it even gives us an example where both would be the same integer of 1 and 1, and our output would be a straightforward 1. All right, things to have into consideration. So n, the input, would always be the height of, or excuse me, where is this n coming from? What are you referencing to by n? You're given an integer array of height, length, n. Okay, so n is referencing the array, and we know that it will always contain the height lengths. We also know that we will never receive less than 2. So that's important. That means that this is likely our easiest scenario. We're not going to receive something where the array will be empty. But it also tells us that the greatest amount that we'll receive is 105 different integers inside of this array. And then our heights can vary anywhere between 0 and 104. All right, awesome. So what am I doing in this algorithm? Am I searching? Am I sorting? Am I conducting mathematical operations? What am I doing?
It looks like multiplication.
You
Okay.
are getting the area of it, so it would end up being length times width, or it'd be height times width to be able to get the area.
Okay, so height times width will give me the area. So that's important to know. And how do I determine the height, right? Well, I would be from the smallest post, because we can see that the highest post is 8, but out of the 2 of those, the smallest one was 7. So let's say here, where height is represented by the smallest post of the pair. Okay, and width, how do we determine the width?
We
The length of the array.
The length between the two indices that you're comparing.
Okay, awesome.
Yeah.
Where width is represented by this space in between the 2 indexes. Think maybe, yeah, let's do that. All right, so there you go. We have an array of 9 elements. We know that height times width will give us the area. But now how do we find this container? How do we go about doing that?
Two pointers.
Good call. Yes, we are looking for a 2-pointer for a 2-pointer answer, definitely. Okay. So now whenever I hear find, that tells me that I'm searching, right? Usually if someone tells me, hey, find something, well, I'm gonna be searching for something. And the 2 algorithms that I know that I can utilize for searching are binary search and simple search. Okay. Well, which one of those sounds like it has a 2-pointer? Like it has 2 pointers that are consistently being compared against one another.
Binary.
Ah, perfect. So a binary search will likely be something that we want to implement here, right? So we want to implement a form of binary search where our first pointer will be at index 0 and our last pointer will be at index -1. All right, so there we have our pointers. We have their locations, and we know which one of our 2 pointers, which indexes are going to be representing our 2 pointers, right? Typically, when we conduct binary search, what we're trying to do is just cut the list in half and then decide, hey, well, now I want to work with this side, and then cut it in half, and maybe now I want to work here, right? Something like traversing fire for those familiar with forward observing tactics. All right. Well, now in this case, if I'm not necessarily trying to cut my list in half, I'm actually trying to find my max container. How would I determine how these 2 pointers get manipulated, or how I close the distance in between them?
Would you have to compare them to all of the like the bars or the points between them and see if they're less than like the value is less than the 2 pointers?
Yeah, so that's
I
a good
guess.
point, right? At some point, we would want to create something like an answer that would hold said area, right? So answer holds area. Maybe that's the very start portion of our code, right? And then something that you mentioned is I want to compare all of them. Do I want to compare all of them and all of their different possible combinations? Right?
Well,
Because
I would say, yeah. Whoever else is go. Sure, I'm still kind of wrapping my head around it.
You'd probably start from lowest index and highest index,
okay,
and then go in from there, because you're going to get your largest volumes of our areas the further out. I don't know.
okay, so we're saying we maybe want a way to slowly close these to one another, right? Maybe like slowly bring it in this way. All right. Well, I think what we definitely want to do is 2 things. One, we want to determine which pole is the largest, right? So at some point, we need to determine which pointer has the longest pole. Once we determine which pointer has the longest pole, well, what would make sense? Let's say that list 0, or let's say we're comparing list at index 1 with our list at -1, right? Which one of those 2 has the largest pointer?
List 1.
Okay, so list 1 has the largest pointer. So would it make sense for me to move my left pointer or for me to move my right pointer? What'd you say?
Left pointer.
Okay, so if I move my left pointer, then I would move to this next one where my pole would only be the height of 6. And then I would be comparing 6 to 7.
I would say right pointer only because you can kind of go through. So the left can maintain like a constant, and then the right is what you kind of keep on seeing whether or not the area increases or decreases.
Okay, awesome. So I'm going to move pointer to one index left or right if they have the smaller pole of the pair. Okay, so then we move our right pointer, and our right pointer is now a -2. And now we have where we have a pointer of 8 and a pointer of 3. Well, we go through the process, we get the area, right? And we probably want to check if current area is greater than answer, then we want answer to be equal to current area. Right? Okay, well, in that case, that doesn't meet our expectation. So we move to the next one. Which one of these 2 pointers would I move? Would I move my right or my left pointer?
Right.
Okay, so I move my right pointer again. Now that puts me at -3. And now I have them where the poles are the same. I have 8 and 8 on both sides. Well, what do we do then?
Well, that would be our answer, wouldn't it be? Because it's the same size as a larger pointer, I guess.
Yeah, it could be, right? But remember that we also have to take into accountability the area, right? So when it comes to a scenario like this, at that point, it really doesn't matter which one of them you move. Just make a choice, whether it's the left or the right, right? So at some point, we have to have an else statement saying, hey, if both poles are the same height, then let's just say we move left pointer by default. All right. Now that will allow us to slowly build into one another. And what would actually kill our loop or our searching algorithm? At what point would we determine, hey, I'm done looking?
Once area can't be greater than your answer. So like, no. Or once list one equals, or the left list equals the list on the right.
Got it. So once the right pointer, so once the right pointer is greater than, oops, I guess I would get these backwards. Once my left pointer is greater than my right pointer, not the value, but index, then I'm done searching. And that would kill my function. All right, does anyone have any questions behind this logic? All right, it doesn't seem like there are any questions. I'm gonna go ahead and share this problem because I don't believe I did. So let me share it here in the Yankee questions. And Gary already beat me to it. Thank you, Gary. Let me go ahead and pause our recording. I hope everybody had a good time trying to solve this. Did anybody encounter a solution?
For the drum
I,
roll.
I did.
Who's was that Tristan?
Yeah.
Why didn't you tell me?
Oh, because you were doing it a little different. I was intrigued.
Oh, nice. All right, awesome. Let's go ahead and take a look at our algorithm here. Here's our double pointer, and let's go into implementing what we know. So let's make a helper function here. We're just gonna have this function say calculate area. And what this function will do is it will take in the height and it will take in the width. Both of these should be integers. And they will return an integer. All right, and we know that height times width will give us our actual area here. So all we're going to return is height times width. I'm just putting that there so I don't have to write it within my algorithm itself. All right, so now I went into the implementation and now of calculating my area, and now I want to actually take a look at these two poles. So we talked about how we would have an answer, which would be an area in this case, where the answer is 0. Then we talked about our left and right poles, where our left would be determined by index 0, and our right will be determined by the length of our heights minus 1. All right? So that's how we get that -1 on the right-hand side. I have my furthest left element and my furthest right element. Then we talked about our killing functionality here. So once my left pointer is greater than my right pointer, so while my left pointer is less than my right pointer, I want to conduct the following function. All right, so we've covered our calculating of an area. We covered our left and right. Now let's go into actually implementing this left and right portion. So we can say, hey, if, let's do width is equal to right minus left, because we know that right is always going to be greater. And then I can say, hey, current area is equal to calculate area, where we pass in the greater one of the two. So let's figure out which one of those two is greater. So let's say tallest is equal to height left if height left is greater than height right, and else height right. Let me open this up a little bit so we can actually see what's going on. So that would determine the tallest, but maybe I want to break this up a little bit because there's a couple of different steps that I want to do in here other than just determining the tallest. So I'm going to go ahead and break that up. So I'm going to say, hey, if heights left is greater than heights right, excuse me, I'm getting a little bit lost in my code here. Okay, got it. So if heights left is greater than heights right, I'm going to actually make a res here for a result because I'm going to need to keep track of multiple results here. Then I'm going to say res is equal to calculate area, where heights left is my height. And then I just pass in the width that I have calculated before, right? So here's my width, and there's my result. So I'm just reassigning it. All right. And then I can determine, as we talked earlier, because my left is greater, then I'm just going to move my right post. So I'm going to say right minus equals 1. In the case where height right is greater, then my solution is equal to calculate area, height left, and width. And in this case, I want it to be height right. All right, so there it is. I'm able to calculate my area and I'm able to move my pointers. Right? I could either move my left pointer to the right, or I can move my right pointer to the left. And I'm creating that squeezing effect, which is what we talked about here. All right, we move the smallest pool. All right, awesome. And this also takes care of the default statement where they would be equal to, because I'm not accounting for equal. I'm only saying if this is greater, then do this. If they are equal to or less than or equal to, then our else statement will be triggered. Finally, we move on to our answer. So I can say, hey, my answer will be equal to res if res is greater than my answer. Else, answer. All right, so I'll go through. It'll calculate the area for our result. And then it's going to check, hey, if my result is greater than my current answer, so my current area is greater than my answer, I am going to set answer to the current area. Else, I'll keep the area that I already had inside of answer. And then once this while loop ends, I will then return my answer. All right, so we start off with our left and rights, kind of like a binary search. We have an answer variable that's on the outside. We move by iterating through left and right, while left is less than right. We will determine the width for those two posts. We then have this variable called results, which is going to hold our current area. We determine which one of those poles is tallest. And I'm seeing a mistake here, actually, because if my left pole is taller than my right pole, I don't want to utilize my left pole's height. I want to utilize my right pole's height, and vice versa. Okay, so I got those two mixed up. So if my left pole is higher than my right pole, I will utilize my right pole's height, and I will move my right pole to the left. If it's less than or equal to, then I will utilize my left pole's height and move my left pole to the right. All right. And now if we take a look at main.py, you'll see that main.py has our examples here for a double pointer, and it also has our answers. So let's take a look at how this works and ensure that it runs properly. All right, good. So we get our true statements. And that is our double pointer exercise. Any questions regarding double pointers? Tristan, did your answer look pretty similar to mine?
Let's see. Actually, yeah, it's fairly similar.
Awesome. All right, great. It doesn't look like there are any questions. We do have retro coming up. So let me go ahead and pause our recording here, or stop our recording actually.